And so I wanted to talk about trees today. Basically, what we're going to cover is how to construct a binary tree. Not a binary search tree, just a tree that has two nodes. So let's just kind of remember about linked lists first and distinguish them from trees. So you remember with linked lists, you had a node, right? And that node had data in it, 7. And then in that node, right, you had sort of a pointer to the next node. Okay. And then that had, some other information in it. And then it had a pointer to the next node, right? So a tree is very similar to a linked list, only instead of having one reference to another node, right? Imagine we just had two references to two different nodes, right? And so this points to this node, and this one, has another node in it that it can point to another thing, right? And then we can have as many other little nodes as we want, so long as we're basically dealing with just two pointers, right? And that's kind of the big difference between a tree and a linked list, is really just that we have multiple pointers, right, to different nodes. Instead of one next, we have two nexts. But we can't call them both next, so we can either call them children or we can call them right and left. So let's talk about how do we do that in Python, basically. So, you'd need a node class, right? Class node. Very similar to your linked list definition of a node. Um, you still need an init to take in self, right? But rather than taking in data and then data, self.data equals data, um, and then only having an x, self.next, instead we have a self.left, to none initially, and a self.right. And so that's kind of our whole node class, right? And so much like when we created a class linked list to kind of hold onto the multiple, to hold the collection of nodes, instead of calling it linked list, we'll just call it tree, right? But it's very similar. F init, right? It's very similar to a linked list in that we kind of do a lot of the same stuff. We will have a self.head, only in this case, we're just going to call it root. And so that's sort of your handle for how to get to the rest of the tree from the top, right? So I'm going to set this to none initially, and that's really all we're going to do. So manually to create our tree without, using a method to automatically insert and figure out where things go, we're just going to just create a tree. So I'll call this tree equals tree. There we go. And I'll say tree head equals node, and I'll put a number in it. Let's call it 6. Tree dot, let's see, head dot left, and I'll call it node 5. And we'll say tree.head.right, and I'll call it node 11. And so then I can kind of do that in as many layers deep as I want. So I can say tree.head.left.left is node of, let's give it a number less than 5. Let's give it 3. And then tree.head.left.right. We'll give it a node of, let's say, 7. And I'm actually, I'll just give this a different number, 9. There we go. So in this, let's sort of draw that out. Let's look at our sketch pad again. This is a pretty ugly one, so we'll just go ahead and erase all of that. So what we'll do is we have our tree, right? And this has 9 in it. And then it has a right and a left. This has 6. or I think 5 actually. And then this has 7, and then this has 3. Over here, we have 11, right? So this is our left, and this is our right. This is our root. And each one of these is a node, and each node has either a left or a right, left or right, or none. You know, it points, all these point to none. So, but each one of them has these properties. And so if we have a node, for instance, like this node here, this node is called a leaf node because both of its children, both of the nodes underneath it, point to null or none. So this is a leaf node and this is a leaf node as well. But this one, we'll call it, will be blue. This is a subtree. So it, because it has children, anytime we're doing something with it, we kind of have to do that same thing with this one as well as this one. All of these have subtrees, but the red ones have none. So that's the basic construction of a tree. That's really all you need to make something a tree. This is a binary tree, but we don't necessarily have to have left and right. We can also have children, right? And children can be a list instead of left and right. And in this way, you know, rather than have this, right, we could have kind of any number of nodes that we want. We can have 4 or 7 or 11, right? Now, the thing that distinguishes this tree from a graph is that there's only one path to any given node, right? None of these siblings have relationships. We don't have any situations where there's a link between these different siblings or here or here or here, right? Um, so that's kind of what makes it a tree. The minute we make this connection, it's no longer really a tree. It's a cyclic graph. So that's how we distinguish that. So, you know, you can have children, and then rather than saying left dot or tree dot head dot left, we'd have to say children, right? Tree dot head dot children, and then we'd say dot append node 5, and then we kind of do that same thing here, right? So, right node 11, and then you know tree dot head dot children of 0 append. So that would be the operation if we wanted to create a tree that is more like this. So, you know, operating on that same node means this here. And this construction is the same as long as you keep 0. You know, our node or our tree is still constructed in much the same manner. It's just that we're not giving each child a name left and right. We're just sort of putting them in one bucket so that we can have as many as we want. So trees differ a lot. There's a lot of different kinds of different trees. We'll get into that later. And in the next video, I'm going to cover breadth first traversal and depth first traversal in different ways. All right. Thanks.